Chapter 11 dealt with simple linear regression. Chapter 12 deals with multiple regression. We're going to look at the solution to the multiple regression problem using the data analysis add-in in Excel. We're going to use the data shown here, cost, size, and visibility, which is the same data shown in figure 12.1. We have data only for 10 hospitals, just as an example. Cost is the dependent variable. It's labeled Y. Size and visibility are the independent variables labeled X1 and X2. Visibility represents the extent to which the hospital administrator is able to compare his hospital to other hospitals in his region, and size is the number of beds in the hospital. We're going to use these two variables to predict cost. In order to do that, we'll go to Tools, Data Analysis, and in the Data Analysis window, we'll select Regression and OK. And the first information requested is the Y input range. So we'll input the costs. And the second is the X input range. And just as with the simple linear regression, we will highlight the predictor variables. It's important to remember when using the data analysis add-in to do multiple regression, the X input range must be contiguous. That is, all independent variables must be in columns that are beside one another. There are labels in the first row, and the output range will be on this sheet in E. When I say OK, the multiple regression output is generated. Let's look at this output. First, we can see here that we account for 69% of the variance in hospital cost using size of the hospital and visibility. The F says that at least one of the predictor variables is a statistically significant predictor of cost, but it doesn't tell us which variable might be. Here are the coefficients for size and visibility. The coefficient for size is a -3, the coefficient for visibility is a -29. What this coefficient says is that when visibility is considered, as the hospital increases by one bed, cost goes down by $3.76. This says that as the measure of visibility increases 1 unit, when size is considered, hospital costs go down by $29.89. This is the standard error for size. This is the standard error for visibility. Here are the t-tests and the probabilities. Both of these probabilities are less than 0.05, so we would say that both size and visibility are real predictors of cost.